This video will present solutions to the 2018 VCE Mathematical Methods Written Examination 2, Section B, Question 3. Question 3. Looking at the graph and reading the information provided, it appears that this question concerns three arches, each of which is a horizontal translation of the others. This understanding helps us answer Part A and B. As the translation appears to be 35 metres to the right, then A will be equal to 40 plus 35, which is 75. And the transformation we are to describe in Part B is a translation of 35 metres to the right. Part C. To find the total area of the shaded region shown in the graph, we can compute the area of the rectangle, and we can subtract the area under one of the arches multiplied by 3. This will be equal to 5 multiplied by 110 minus 3 times the integral from 5 to 35 of h1 of x dx. This calculation can be performed on our class pad. And that exact value to the nearest square metre will be 264. Part D. This part concerns a second bridge that has arches quite similar to the arches in our first bridge. Our first computation is to calculate the gradient of the second bridge, and this can be done using the identity m equals tan theta, or in this case, tan of pi on 90. This has an approximate value to 3 decimal places of 0.035. Part E. Part E draws us to point P on arch 5. At point P, the tangent to arch 5 has the same gradient as the second bridge. And we can use this information to find the coordinates of P by equating the derivative of arch 5 to the gradient of the line found previously. In other words, we want to solve h2 dashed of x equals tan pi on 90, given x is between 40 and 75. I'll change the function from the first arch to the second arch by changing the 5 to 40, and now we can differentiate. This answer will be equal to tan pi on 90. And now I'll solve this equation. I want a 2 decimal place value, so I'll use a numerical solver, and I want the solution between 40 and 75. This gives us our value of x, 54.36. Our value of y can be found using the function. And a value of y, 4.988. to 2 decimal places. Part F. Part F directs us to point Q, which is on the second bridge and on the perpendicular line PQ. Using this information, we can find the equation PQ as it is perpendicular to the bridge, which has a gradient of tan pi on 90. Using this information in our class pad, we can find the equation of the line. If we provide the x and y coordinates of point P, we can find C to complete the equation of this line. This gives us the equation of the line y equals -1 on tan pi on 90x plus 1561.73. We can now find the intersection of this line with the line of the bridge. The line of the bridge will have equation y equals tan pi on 90 x plus 5 based on its y-intercept. And this gives us the coordinates of point Q. Now the distance PQ can be found. Using the distance command that I have pre-programmed into a user-defined function on my class pad. I will also need the coordinates of the point P. My value to 2 decimal places will be 1.91.